Energy types. Our essential question is what is energy and how can I tell what kinds of energy are in a system? The question, what is energy, is a simple question, but I know that it's kind of complex to think about what energy really is, what it means for an object to have energy. And I want you, by the end of this lecture, to be able to look around you at any object in the room and be able to think to yourself and describe what kind of energy that object has, because every object has energy. Everything you see has energy around you. So we use this shorthand E to represent energy. And the very simple definition of energy is the ability to make something happen. The other definition you might see if you look it up on the computer is the ability to do work or make something change, is the way to think about energy. And I like to give you this example of a car driving down the road has energy. And we know that it has energy because A, it's moving, like it's changing location. And B, if the driver slams on the brake and makes the car slow down, which is change, um, and it skids to a stop, there is this black line that's left on the road. It made a change to the road, so we know that the car has energy, or had movement energy in that case. There are two categories of energy. All energy is either in the category of kinetic energy, movement energy, or potential energy, stored energy. And the word itself, potential, is the potential to make something happen. It means it might not be happening quite yet, but it has the potential. It's in that position. It's in that possibility of creating that change. The typical units that we use to describe energy are joules, or calories. And calories, we're talking exactly about like calories, just like those that you eat. You might have a pretty good idea about what a small amount of calories are or a large amount of calories are in food, but I bet you're pretty unfamiliar with what a joule is and how much energy that would be. So I'd like to give a few examples here to help you to wrap your head around it. So stretching out a rubber band like that, it is just a few joules of energy. It really doesn't take much energy to stretch out that rubber band. And I also like to think about it in terms of how much it would hurt, like how much energy would be that rubber band would be hitting me with. If that rubber band were to snap and hit me, I'd go ouch, and I would be okay, right? It's just a few joules of energy. Um, let's step it up a notch. We have about 10 joules of energy from that falling apple. Might hurt a little bit more. Still not a ton of energy there of that falling apple hitting Newton in the head, that story. I don't think that's a true story, but whatever. Anyway. Kick it up another degree of 10. We have a basketball that this woman is spinning on her hands. Now, okay, imagine that she loses control of the basketball and it hits her in the face. That hundreds of joules of energy is going to hurt a heck of a lot more than either of those other two examples. I'm not saying that energy always hurts, but it helps me to understand like how much energy there is. So I don't know. That's the way that I like to think about, thinking about joules. If we're talking about thousands of joules, well, we have this horse, which has a tremendous amount of mass. It's a really heavy animal and it's moving really fast. Thousands of joules of energy. That horse could obviously do a ton of damage if it were to run into you. Okay. So, kinetic energy types. Objects or pieces of objects have kinetic energy if they or parts of them are moving. So, I'm going to run through some types of kinetic energy we have here. We have, again, shorthand E, lowercase, and then M is motion energy, rotation energy, that is things that are spinning. I'll draw a little spinning there. Thermal energy, we're talking about heat here. I'll make a little fire. Maybe add some logs to that. Beautiful. Okay, there we go. Light energy and wave energy. All of these types of kinetic energy, all of these energies are energy of movement. Let me go back to my pen. moving. Okay? That's the key here. We have movement. Now, whether something has a small amount of energy or a large amount of energy is really dependent on two things: about how much mass that the object has. It's not quite the same thing. Like mass and weight aren't quite the same thing, but at least here on Earth, you can imagine mass is how heavy something is, and how much stuff is in there. Right? That's literally what mass is: how much stuff. But how heavy something is, way you can think about that, and speed. So when you are thinking about whether something is going to have a small amount or a large amount of kinetic energy, you should really think of those two things. How massive is this object, and how fast is it going? The one exception to that is light energy. Light doesn't have mass. If you want to get into that, we're talking about you need to get into some calculations around um, why light has energy and has to do with its momentum. You can chat with me or chat with the AP physics teacher about that. Everything else, though, we're talking literally mass and speed. So here's our example of a small amount of motion energy, a turtle, and a large amount is a race car. Yeah, small amount of mass, not moving fast, moving really fast, very massive. Rotation energy, we've got a bike tire and a planet. Thermal energy, um, ice and lava. Okay, a little note about thermal energy here. Um, we are talking about the pieces of objects, like if we get down to the really, really small level, we call it the molecular level. These molecules are moving in ice really, really slow, and in lava, it's moving really, really fast. Um, no worries if you're not really sure what I'm talking about when I'm talking about molecules, but ice is cold, lava is hot, low thermal energy, high thermal energy. A light energy flashlight and laser. This will hurt your eyes, this will not, right? Yes. Okay. And last, wave energy. When we talk about waves, we're talking about sound, and we're also talking about physical. Sound is also physical. You feel that when when you have a sound that's really loud, you feel that vibration. But sounds and then water waves fall into the same categories. So a whisper and a tsunami. That's clear. That's great. So potential energy types, objects have potential energy if their shape or position stores energy. And so our types of potential energy are gravitational energy. This is energy from height. And again, mass is still involved with this. How do I get back to my, there we go. So we can think of this as height. Height. Electrical energy. Think about like a big shock and a little shock. Spring or elastic energy. In this is an S here. I also often use an E to represent electrical energy, elastic energy, a small e, not to be confused with the electrical energy there. You can use an S or a lowercase e. You just might see me use the lowercase e. I often forget about the S. Um, Chemical energy, that's like food. We're talking about chemical energy there. And nuclear energy. So gravitational energy, small amount of snow, large amount of space shuttle. Space shuttle's way up higher and it's way more massive. If you imagine both of these things coming crashing down, that snow's not going to crash very hard. That space shuttle is going to have a tremendous amount of energy. Electrical energy, an electron is like a tiny, tiny particle. I think another great example would be like a let me think about um like static electricity from a balloon. I don't know if I want to write that in, but like static electricity from a balloon would be another one. I can draw a little balloon there. Electron is a tiny particle that and then a power line is like a ton of electrons that are flowing through. Spring or elastic energy, we've got that rubber band from that previous example, or we have car shocks, to jumpstart a car. If the battery dies, then you need to have a lot of energy to get that car going again. Chemical energy, one single peanut doesn't have a ton of energy in it, or a battery that, you know, powers your battery powered toy, whatever. I'm losing my mind right now. Okay. That battery does have a lot of energy. And nuclear energy, yeah, bananas actually do have nuclear energy and the potassium in them, but it's not very much. Or we have, when you think about nuclear energy, you think about nuclear reactors. So those are those types of energy. All right. So in summary, you will answer the essential question: what is energy, and how can I tell what kinds of energy in a system? I'd like for you to also add and how much. And how much? Much. Oh boy. Okay, that says much. Great. So your mastery check. Sorry, I just cleared the screen. You can go back. Your mastery check will be for you to answer this question using examples from the lecture or from your own imagination, in paragraph form. So that's the whole mastery check. It'll be a little half sheet for this particular lecture.